We are looking at enhancing the secret messages project from the YByte Python curriculum available at www.ybyte.in. One of the encodings that we saw in our class was this, what we call swap middle, where the idea was that I took the original string, I divided that into two parts, the first half and second half, and I just interchanged those two. Now, clearly, this was a good, practice in slicing and programming. But as an encryption, this is not all that great because even after encoding, for example, it says is cool Python, it's kind of easy to decode. The good thing, however, was that I could, decode this by just repeating the whole process. I just put these two halves back and then I get the original message. But the question is, why can't this be generalized? And that's what we are going to look at this. Let's see how we can generalize this. Let's say instead of doing two chunks, let's say I decide to do three chunks. Now, clearly, when I do this, every chunk is going to be of the length of message by n chunks. N chunks is the number of chunks. Now here I have a key according to which I am mixing these up. So for example, my key here says 201. What I mean is that the first chunk, which is the zeroth chunk, will go to be the second chunk in the, after encoding. The first, like the zeroth, first and second. So the zeroth chunk becomes the second chunk. The first chunk becomes the zeroth chunk. And finally, the second chunk, which is the third really, becomes first, right? So I go according to this key and I move these chunks around. Notice so the message is a little bit more encrypted now. And clearly, this is a bit more mixed up. Of course, I can extend this further. I can say instead of three chunks, I'll use four chunks. So again, I have a key. The zeroth chunk here ends up being the first chunk in the encoded message. The first chunk here ends up being the third. Second ends up being the 0 and third ends up being the 2 because my key is 1302. Now clearly this is much generalized, and if you keep extending this will eventually become quite random and could be quite powerful, but obviously it has to be accompanied with this key. So let's see how we can do this. It's really not that hard. What we need to do really is, number one, to ensure that the message being encoded is of a length that is a multiple of n chunks, because if that is not the case, then we'll have to add some spaces, otherwise we'll run into some strange problems, right? Once I do this, I create slices of this message, right? Now these are contiguous slices because I'm taking the entire chunk together, and each of these slices has a length of len message divided by n chunks, and that's quite reasonable. And finally, I move these chunks to, let's say, the positions as indicated in the key. Now, again, all this is quite similar to the other generalizations that we have done. The code would be basically not too hard. First thing first, I go and add, appropriate number of spaces. Notice I'm passing here number of chunks as a input. So I just find out how many, I must add. I just go that. I just add that many spaces. Next, I found out the length of each chunk, which is indeed length of message divided by n chunks. I convert this to integer because this division itself will give me a float. Now I move this as it was determined in the key. So which will basically, so if the key is say 2103, kk will become 2, kk will become 1, then 0, then 3. I will get the temp, which is a slice of the message accordingly. Remember, this is kk times m, kk plus 1 times m in steps of 1. So I'll get the appropriate slice and I'll append that to s. So that's how it'll go. So this is not too hard really. Let's just see this in action. We can come here. I will pick up one of my earlier codes to sort of let's say I go and pick up, let's just take this, what I call transpose general. Let's take this code, so I'll go with the key of say 2013. So we'll divide this message, let's say, in 4 chunks. I'm going to call this, let's say, swap mid general, right? So that the name becomes a bit more clear. So swap mid, say, general. Now here I'm going to call it, let's say, n chunks, right? Say n chunks and the key. So let's just define this. So I say n chunks, maybe I can do this later also. Now notice, since I'm calling it n chunks, just for the sake of clarity, I'm going to change this to n chunks. Chunks. I also will make sure that this is all n chunks, right? Of course, I could have called it n, doesn't matter, but just for the sake of clarity, I'm just going to make it all, say, n chunks. So this ensures that my number of, the chunks that I create are all, I have enough number of letters and equal number of letters, right? Now I'm just going to go, let's say, kk in key. Of course, the slicing has to be happening, and I'm going to find the length of every chunk. So I go and say m is equal to, for example, len of messages. So len of message, okay, be careful, len of message divided by, say, n chunks, and I'll convert this to an integer because this alone will give me a float. So I go and convert this to an integer. I go for kk in key. I just have to sequence this nicely. So it will be kk times m to kk plus 1 times m, and finally this step size has to be 1 because I'm getting basically contiguous chunks. Now I made a mistake here, let me be careful. This should be small kk, right? And pretty much this is what I need to do. I can see this working. So let's say my x was whatever it was. Let's say I define my n to say n chunk is say equals to 4, so which means I'm splitting this in 4 chunks. And my I call this function as swap say mid say general, and I just do this for my message here. I say, for example, let's say n chunk, because number of chunks is 4, and I'm defining a key here. Let me just define the key to be, let's say, say for example, say key is equal to say 2103. Now clearly the key has to be a list which has all the elements from 0 until n chunks minus 1, right? So I just go and say take this with key, and let's just give some name to this variable. So I say x say swap mid gen. Now these names are becoming quite long, but never mind. So I'll just call it mid gen is equal to swap mid general, right? So let's say if I run this, what do I get? So if I look at my x is of course meet me in the lobby. If I look at x swap mid gen, now notice it has converted this into chunks, 4 chunks, and it has possibly moved them around because of this key, right? So basically lobby has come in front, in the meet is still in the in the is somewhere in the middle, meet me has come here, and at 6 p.m. has come here. So that depends on the keys. 2103, which means 0 chunk went to 2, first chunk remained at 1, second chunk came at 0, and the third chunk remained at 3, and that's what we are seeing there, right? Now obviously if I were to use a key of, let's say, 0 1 2 3, then nothing would change. I expect my message to come out as it is. In fact, if I look at now x say swap mid gen, which is variable, it's exactly the same because my key is 0 1 2 3, and really all it means is that I moved every chunk to wherever it was. Now this has kind of generalized this. Keep in mind, however, that now the decoding is not that simple. I have to undo this movement, and it's actually quite similar to all the other generalizations that we have done. We will see this in a subsequent video. I hope you found this interesting. If you find that this way of learning works for you, you find it engaging, look at our website because there are many, many such videos. Take care. Thank you so much.